You have now dealt with the quotient rule and the product rule, so what we're going to do is look at introducing the idea of substitution. Okay. Later in the course, you will discover something called related rate problems when applying differentiation, usually involving rate of change of volumes, area, so forth. And you may be given things with respect to time, the radius, the height, the volume. Find the rate of change by manipulating information. This is called related rates. And what you'll find is that you might be given something, no X, you can see, you've got a V, an R, an H. So you might be asked to find dV by dr, or dV by dH, or dV by dt, radius in respect to time, the height in respect to time. You could be given a whole variety of issues and you have to learn how to manipulate it. So we're going to use the idea in substitution as well, and it helps us with the chain rule. But before we continue with differentiation and maybe more complicated things you can't just do mentally using the chain rule, we're going to look at how to make this, and not all functions are simple, so how to make it easier for you. So let's start with easy. How would you differentiate that? You would do that mentally. You bring the 5 down, it'd be to the power of 4, and then the chain rule would come out with 2. Then you'd say 5 times 2 is 10, and that's it. That's easy, isn't it? You don't need any other tricky formats there. You don't need substitution, but I'm going to use this to help you see how I could tackle trickier problems later. Okay. Substitution, therefore, instead of differentiating and using the chain rule mentally, we're going to look at, normally it's what's inside the brackets that we'll substitute U for. Okay, we call it the most awkward part, but it really depends on the question. Later in integration, they'll tell you what they want you to substitute in as well. This creates an issue, as normally you have dy by dx, but now if you start involving u, then you have to solve a problem that has 3 variables. So how on earth do we deal with that? Well, let's start with a more basic algebraic problem. If I have a over b, what if I decide to add a third variable in c? A over b is the same as dividing both by c. So if I divide both by c, then a is over c and b is over c. It still actually reduces down, and I'll show you maybe in a nicer way. Okay, you know this is division, so I've just wrote the exact same there, but wrote it as division instead, because you know KFC means keep, flip, change, so it's a over c times c over b. And I said it's the exact same, it's just you've introduced c, you can see that they could cancel down immediately. So this means that you've involved more items, and you could have it with volume and radius and time and so forth. You can do it with lots of things. So related rates involves this. You're not doing that just now, but it's just to show you that you'll see things like this at a later stage. Okay. You can do it with differentiation too, as I showed you with the volume there. If I have dy by dx and I want to bring in a different variable, and we're going to call it u, then what did I do with the c before? If I divide both by it, so it's not by the u, it's by du here, so that means that you could express your derivative in terms of u as well. You know that means division, so if I just do this and then keep, flip, change, you'll see that I could instantly cancel those out. So again, similarly, you could have different variables, but it's the same idea that you could cancel them down a bit. Okay. Okay, so let's go back to that more simpler question with 2x plus 3. How do I do it? So it's to the power of 5. When I say more awkward, I mean this part's the part that's more awkward in the bracket. So I'm going to let 2x plus 3 be called u. The next thing is, if you have 2x plus 3, you need to differentiate it. So we decide what's awkward and set it equal to u and then differentiate. The next step is that that's no longer y equals in terms of x. If you have decided to call that u, then y equals u to the 5. So you decide what u is, differentiate it, and then you represent your y in terms of u, and then it's easy to find the derivative in respect to u. Okay. What do you do then? If I write the rule down, actually what you do is you take the two derivatives and multiply them together. You have dy by du, which is 5u to the 4. You have du by dx, which is 2. And you'll see that for you to get dy by dx, it's the combination of them both. So it's 5u to the 4 times 2. You just take the derivatives then. Okay, 5u to the 4 times 2. But at the end of the day, you've got to get it back into the x format. So now we're going to put back in that u is actually worth 2x plus 3. You could have multiplied the 5 and the 2 right there and then as well. And then, in fact, you get the same as the original answer. Substitution was not necessary there, but it was just to show you what I have done. So I took the bracket, or the more complicated part, and set it to u, differentiated it, and then rewrote y in terms of u, differentiated it, multiply, multiply. Let's do it with another one. So what's the steps? Decide what you're going to set to u, find the derivative of that. Remember what you've set equal to u to express y in terms of that, find the derivative of that, and then multiply them together. Here we go. What about sine squared x and sine x squared? Because people find them confusing. This one means that it's all squared, a big bracket, or the sine part that's squared, whereas this part's the x. So they're both different, but people think they're the same at times. Right, I'll do the mental part afterwards. So what did we do before? This means sine x all squared. So what's in the bracket's the most awkward. So I'm going to set u equal to sine x. What's the derivative of sine x? Cos x. Okay, so what's in the bracket? Set to u, differentiate. That's it. The next part is you now have y equals, and it's not in terms of x, it's in terms of u. You have said that's worth sine x, so y equals u squared, differentiates really easily. What do we do to find the last part? You multiply the two derivatives together, 2u times cos x, and then substitute back in u. U is sine x. And then, actually, if you want to be super smart, that is a double angle formula. You could make it sine 2x. Be super smart. How would you do it mentally? Because to be honest, I wouldn't use substitution. I'd bring the 2 down to the power of 1, but then the chain rule brings out cos x. So then you can have 2 sine cos x, and you could make it sine 2x as well. So again, I'm picking ones that you don't necessarily need to use substitution for, but showing you it's available to you. Right, okay, let's go for sine x squared. That was the other one. So this time I'm going to let u equal x squared, so it's 2x is the derivative. This time y is sine u, so that goes to cos u. Remember when we go to differentiate this, it's the derivative dy by du times the du by dx, just this derivative times this derivative, cos u times 2x. Cos u was x squared, it's just cos x squared, but I'd always bring the 2x to the front. That's your answer. How would I do it without? Again, you could do this mentally. This time sine goes to cos, and it's x squared. So this is where people get confused, because that is just where your angle is, what you are putting into the function. So it's actually the function that you're differentiating there. So you've got sine goes to cos, and then the chain rule comes out as 2x, and then you get your answer. So again, you do not need to use substitution there, but it's in case you're getting over confused about things. Let's try it for sine x cubed. Sine x cubed means it's the x that's cubed, so let u equal x cubed, then du by dx is 3x squared. Y would be sine u then, very similar to the other one. How do you differentiate? It will be the derivatives multiplied together. Substitute in, that was x cubed, remember, and you get your answer. That's it. Cos to the 5 isn't with the x, so what I would suggest is you write it like that. That means that for substitution, I'll let u equal cos x, so the derivative, remember, goes to minus sine x, and then that will be, I'm not writing it f of x over here, I'll write it as y equals u to the 5, so then it goes 5u to the 4. Multiply, multiply, but the difference is I'll write f dashed x here, so that will be 5u to the 4 times minus sine x. Bring the minus to the front, in front of the 5, substitute in that u is cos x, and you'll get that. If you want, you can bring the sine x to the front and put the power at the end, but I wouldn't put the cos in the big bracket, I'd say cos 4, okay, cos to the power of 4, okay. It doesn't matter to me whether you write minus 5 sine x cos 4 to the 4 to the x. I'm saying that wrong, but never mind. What you do here, you bring that up to the power of minus 2, And then how do we deal with it? That clearly to me is the most awkward part, the part in the brackets. I'm going to set u equal to that, so the derivative will be minus 5x to the 4. Instead of f of x, I'm going to say y equals 7u to the minus 2. So then differentiate, that's okay. Derivative times derivative, minus 14u to the minus 3 times minus 5x to the 4. Minus minus turns to plus, the numbers multiplied give you 70. I'll keep x to the 4 upstairs, but I'll bring that down as a negative and just make it positive. And lastly, you know that u is 1 minus x to the 5, so you can write it like that. That's perhaps when you would like to start using. You can use it at any time. If you can use the chain rule mentally, that's fine too. Okay, 1 over cos x is the same as cos x to the minus 1. So I'm going to let u equal cos x, which means that the derivative goes to minus sine x. Now I have 1 over u, or u to the minus 1. So then I can find the derivative, no problem. Multiply both derivatives together. Bring the negative index downstairs. Minus minus turns to plus. And then you've got cos. Now you can do something else with this. Cos x squared means cos x times cos x. So if I split this so that it's sine x over cos x times 1 over cos x, you actually have tan x over cos x. Okay? And you'll learn other things soon too. Okay, you're going to try these now. You'll find that these are on page 19 of your PDF, and then the answers are to follow. So you'll find the answers are after this, so you can go through them all, okay, but that is page 19. That is your task for substitution.